So today we will see the set interface. Yesterday we saw the list interface. Inside that, which property we saw? That are the classes now: array list, linked list, stack, and the vector. In the inside the list, what we saw means which are the properties: insertion order, index base, multiple null values we can store. Mean duplicate values it will allow it. Okay, another one is insertion order. It is allowing also
not synchronized.
non-synchronized, but two classes are synchronized. Which are they? Vector and stack. So vector and stack, which are the means what we call that legacy classes. Why?
Those are implemented in JDK one.
Before collection, we are using that classes to add to means to manipulate on the object, to store the object or to manipulate the object. See, this is the difference. List is an index based, but set is not a index based data structure. It stores the data according to the hash code values. Hash code values it will store the data. Okay. After that, set does not store the duplicate element. Means what it will do? If we try to add multiple means same value multiple times, it will not add. It will consider as only one time. Okay. Set can store only one null value. Means only one null value we can able to add. Means if we add two or three null values, it will consider as a one only. Set does not follow the insertion order also. Means whatever order we can add the element, no, that we cannot get. Okay, it will not follow the insertion order, and we can iterate the set element by only the iterator, not by the least iterator. Least iterator is present here only inside the list interface, not in the set interface. Okay, so now we will try to create. And what are the classes present inside the set interface? The hash set, linked hash set, and the tree set. Hash set, see, I will tell you in short. Hash set, it will not follow the insertion order. Inside the hash set, it will not follow the insertion order. Inside the link hash set, it will follow the insertion order. Okay, remember this thing. Hash set, it will not follow the insertion order. It will add the values on the base of hash code. Inside the linked hash set, it will add means it will follow the insertion order, and inside the tree set, it will follow the sorting, because it is implementing the sorted set. So it is following the sorting. That is the difference only. Okay, so we will see first hash set. What is meant by hash set? First we will come here. Okay. So if I want to create a hash set object, how we will create? New hash set. This one. Okay. If I want to add the values, how we will add? Hs dot add. So firstly we will try to add different types of elements. Java firstly I am adding here. After that hs dot add. After that integer we are trying to add hs dot add. Character we will try to add. This time and we will try to print this one now. And it will be print. If I print this one, so what will be the output? Any guesses? It will not follow the insertion order. If I run this one, see, Java C and 1.2 and 10. It is following insertion order or not? It is not following that, right? Suppose I am copying this one 10, and if I print multiple times, okay, C is also we will try to print multiple times. Okay, now what will be the output? Only one time it will print, right? If I run this one, the Java C 1.2 and 10, only these are printing. It will consider C as a one time, 10 as a one time, and another 10 and C it will consider as one time. We have wrote multiple times, no? So it will be considered as a one time only. Okay, if I add null value, which is dot here, if I add null value, can it will take only one time it is printing. If I copy this one, if I print this one multiple times, now see, only one time it is printing, right? So if I write multiple null values, it will not allow that. inside the set it will not allow the duplicate values, right? If I write multiple times also, what it will do, it will print, it will consider as a one time only. See here we have added null values multiple times, so it will consider as a one time only. Here we have added 10 multiple times, so it is considered as a one time. Here can we add heterogeneous type of value or not inside the set? Yes, no, we can add heterogeneous type of values, multiple types of value we can add inside the hash set. Can we add here the null values?
Yes.
Only one we can able to add. Duplicate values it will allow? It will not allow, right? So this is the hash set. We to difference to see the difference between the hash set and linked hash set. Similarly, I am creating one new linked hash set here. We will see the difference. Okay. Now we will try to add here same thing, ls dot add. Okay. Here we will add this thing, that is the same. Another one we will add ls dot add. Here we will try to add another. Okay. ls dot add another thing I am adding here. Null value we will try to add here. Similarly, and character. So inside the linked hash set, see what will be the output. What it will print inside the linked hash set? It will print insertion also. First it is printing 10, then C++, then 1.5, then null, and then C. Okay, if we see the information about that, let's see the theory. Interface. The set interface present inside the java.util package, and where is the collection is present? Inside the java.util package, collection is also present, and extend the collection interface. Set is extending the collection interface because set and the collection both are the interface. That's why we use here the extends. Okay. After that, it is a unordered collection of objects in which duplicate values cannot be stored. Unordered means not follow the order insertion order. It is an unordered collection of objects in which duplicate values cannot be stored. We can store at most one null value in set, means it will allow only one null value. We cannot able to add multiple null values here, right? Set is implemented by hash set, linked hash set, and the set. We have three classes inside the set interface. Which are they? There is the hash set, linked hash set, and the preset. Okay. First one is hash set. Hash set class implements the set interface. It is represent the collection that uses a hash table for storage. So which is used for the storing this one. That is the hash set. That is the hash table. It is using hash table for the storage. After that, the object are inserted on the base of hash code. On the base of it will store the values. Okay. On the base of hash code, it will store the values, and it is used hash table for the storage. Hashing is used to store the element inside the hash set. Okay. Hashing is the one of the technique. It is used to store the element inside the hash table. Okay, and it contains only the unique elements. Means it will not store the duplicate element. Okay, this is the properties of the our hash set. Okay, anyone have any doubt here? Hashing and hash table, what are they? You have to learn by yourself only. Okay, otherwise what is their name? My will told, I will tell. Okay, after that we have another class, that is the linked hash set. Linked hash set class represent the linked list implementation of the set interface. What it is doing here, it is represent the linked list. We learned linked list, right? So means how linked list will work.
It will follow insertion order. It will allow duplicates.
No, so means on which data structure linked list is follow? Index will, that is okay. Linked list data structure I'm asking. Which data structure it is follow? Doubly linked list. Doubly linked list it will follow, right? So linked hash set class represent the linked list implementation of set interface. After that, it extend the hash set class and implement the set interface. Means what it is doing? It is extending the hash set class and implements the set interface. Means here it is extending hash state also and implementing the state interface also. So what are the properties here? Means what are the methods are here in the state interface? All are present inside the linked hash state. After that, like hash state, it also contain the unique element. Means if we want to add the duplicate element here, suppose C++ we can add multiple times. So can it will print yes or no? It will print only one. See here, what is here? Like hash shade, it also contain unique element, not the duplicate element. So it will not also allow the duplicate element. Inside the all state interface means what are the classes present inside the state interface? No, that will not allow the duplicate elements. Okay, that is only store the unique elements. What are the unique elements they have? Only they store. Okay, that elements only they can store, and it maintains the insertion order and permits the null elements also. Why they are saying like permits null element? If we saw the another class as the tree set. If we create another class for the tree set here, new tree, here I am writing ts. Okay. ts dot add. Suppose I am adding here multiple values, same like that. In suppose I am copying this thing here. Okay. So 10 C++ like that I am adding ts. Now what will be the output?
It will print sitting one.
It will print in ascending order. We will see. So first we will take only that only integer value we will take. No? 20 here. I am taking 90. That here we will try to add one. So I am adding here is the string. So it will print or not. Here I have added null values also. So it will print or not. See here. 65. Now what will be the output? Suppose I am removing this one. These two things I am removing. Just commenting this. Now we are seeing only the reset. I am printing here TS. Now what will be the output?
Yes, one. It will not
It will print or not?
null pointer exceptions you get.
See, we will try to run this one. See, we are getting here null pointer exception because inside the tree set we cannot able to add null values. Okay, inside the tree set we cannot able to add the null values. And if I remove this null from here, now what will be the output? In the ascending order we will get, see, 1, 5, 10, 20, 65, 90. Means tree set follows the sorting order. It is following insertion order. No, right? It is following only the sorting order. Right? If I want to iterate this one, how you can iterate? Es dot iterator, and it is returning one object, that is the iterator object, right? And if I print this one here, while after that itr dot next. What this method will do? It will boolean value, right? And after that here we will print system dot out itr dot next. Simply, if I run this one now, what will be the output?
It will print one.
Like that it will print. Suppose I want to print in the descending order, how we will print that?
Previous. Next.
Previous, yeah, no method. Has previous.
Uh,
Has next and hash code is there only.
link to Linked list only you will
Here you can see that the set uses the tree data structure for the storage. What it is using? It is using the tree for the tree data structure for the storage. Okay, like a hash set, tree set also contain unique element. Means here if we add the same thing multiple times, so how many times it will print? Suppose I'm taking 90, I'm printing 2 or 3 times. Now if I run this one, so how much time it will print? Only one time, right? So it is printing as next year we are getting. See, we are getting 1, 5, 10, and 90 we have printed multiple times, but it is not printing here, right? We have added 90 multiple times, but it is printing only one time, right? Here, another one is that, see, the access and retrieval time of the tree set is quite fast. It is faster than all the classes which are present here, right? So tree set is mostly used for accessing and retrieval. Okay, it is mostly used for accessing or retrieval. If you want to access any element or retrieve any element, that we will use the tree set because it is quite faster. Okay, the element is tree set stored inside the ascending order. Just now we saw that means it is following the sorting order, right? And but we can iterate in the descending order using the method descending iterator. If you want to print this all the things in the descending format, how what we will use? Descending iterator. Simple. We will write here es dot descending iterator, and it will return one object. So I'm writing here disk. Okay. And after that, simply same like that, we will iterate this one while inside the while. Simply we will write disk dot text, and simply here we will print system dot out. Now if we print this one, what will be the it is printing in the descending order 90, 50, 20, 10, 5 like that, right? So this is the tree set, means it is uses the data structure tree data structure for the storage, and it contains the unique element. And if you want to means if we add any null values into the tree set, so it will allow that. No, right? Preset is not allow the null values. If we add, so it will give one exception, that is the null pointer exception. Another thing is that if you want to print all the elements in the descending format, that time we will use the descending iterator inside the preset only. Okay. If you want to print in the descending format, that time we will use the descending iterator. So that is all about the preset. We have a multiple classes here. Inside this one, we have this much class. That is the hash set, linked hash set, and the tree set. So what is the property for the hash set? It will not follow the insertion order or the sorting order also. It will add the values on the base of hash code, right? We have another thing that is the linked hash set. So how it will add the values? It will follow insertion order or sorting order. It will follow the sorting insertion order. After that, we have a tree set. So how it will add the values? It is follow the sorting order. It is not following the insertion order. And here we cannot able to add the null values. And all the classes which are present inside the set interface, that is accept only the unique values, not the duplicate values. If we add duplicate values, means it will print only one time. It will consider as only one time. Okay, so that's it, or that's all about the set interface. Okay, in short, I have tell all the things. Means you have to practice on that. Okay, all the things you have to practice on that, because we have very less time. That's why I have to be in very short. Okay, so now we will see the generics. Okay, what is meant by generic? Generics is very easy. Simply I will remove all the things. Okay, here suppose I want to create a like a collection object of the array list. So how we will create new array list? Array list here. I'm getting. You can take anything. I'm taking array list here. Okay. Here I'm removing this thing. This is called as l dot add. Simply I'm writing anything here. This is 10. First I'm adding. After that l dot add. Simply I'm taking another thing here. This is this Java. Okay. L dot add. Simply I'm writing here the another thing. Same like that, same thing we will add multiple. Here I am testing. Okay, simply system.out. If I print this one, what will be the output? It is follow insertion order. Okay. If I run this one, so it will print like that. Suppose many times what we require, we want to add the same type of element inside our collection object. Okay. Sometimes we want only to enter the integer type of value inside our collection. That time we will use the generics. Okay. That time we will use the generic. Simply what we need to do, simply here we have to create like that. And here if I want to add only integer, so here we have to write the wrapper class integer. Okay, this is integer, and similarly here also we need to add the integer. And now if I add integer here, see, for for the string it is giving the error, for float also it is giving the error, for another string and float it is giving the error. Suppose I am removing this one and I am adding here only, it is not giving the error this time. If I remove this one and here I am adding 65, it is not giving the error. Now which type of value we can able to add here?
Only integer.
Only integer type of value. And here remember one thing, here we need to add only the wrapper classes. Okay, not the data type, we have to add the wrapper classes. And here also we have to add here scale. Okay, and here, okay. Now if I add all the integer type of value, it is not giving any error. Now we can able to add here only same type of value. Okay, sometimes we need that, no, means we want only the integer type of value. That time we will use the generics. Okay, that time we will use the generic. So some simple another way is that simply I am removing this one and this one also, generics I am removing. Now I want to get this value. Okay, so how we will get that? Simply we have method here dot get. Okay, and which in, yeah, means suppose I want this 12, so what is the index? 0 1 2. Simply I am writing 2. I want to get it into the integer type, int a equals to, like that I am getting. Okay, but I told you this is not a, this is not a integer, this is a object. Object I am storing into the integer. So can I able to store that?
No.
No, for that we have to typecast, right? Simply I am typecasting it. So I am typecasted, after that it is printing, right? It is storing into the a. Suppose I will print that a again. A. Now if I run this one, it will be run. See, 12 is printing. Now if I use here the generics integer, okay, and here also we'll use the generics again. Okay, now if I remove this typecast, it is giving any error? No, right? If we use the generic, if you want to get any value, that time we no need to typecast it. Okay, that time we no need to typecast. If you want to store this value, there we don't need to typecast it. Okay, this is the advantage of the generics. If you want to store the same type of value into the collection object, that time we will use the generics. And another thing is that if you want to get the values, that time we no need to typecast it. Okay, the two advantage of the generics, and it will give the error at the compile time. See, dot add. Simply I am adding here string. So it is giving the error at the compile time. So it is best for the programmer to get the error at the compile time. So that is the another advantage of our generic. That for this at three advantage only we are using the generics. Okay. See, we will see some theory about that. Same thing we have written. Is the generics. The Java generics programming is introducing J2SE5. Okay, it is introducing J2SE5 to deal with type shape object. Okay, if you want to use only same type of element, that time we will use the generics. It makes the code stable by detecting the bugs at the compile time. So where at which time we are getting the bugs? At the compile time only. So this is the good for the programmer only. Okay, after that, before generics, we can store any type of object in the collection. If we are not using the generics, we can store any type of collection object, right? Sorry, any type of value inside the collection object. Simply if I remove this one, if I remove this one means I can able to add multiple null value, string value I can add also. I can add integer type of value also. I can add character type of value. And now if I given here the integer, which type of value I can able to add here? Only integer type of value. Suppose I am writing here string. string I'm writing here. So which type of value we can able to add here now?
String values.
String value, right? If I run this one, it is giving the error at the compile time only, right? Another thing is that the advantage, that is type safe, we can hold only single type of object in a generics. Means we are making our object as a type safe. Okay, it doesn't allow to store other objects. If we write here the string, it will allow only the string type of value. Okay, it will not allow the integer or character like that. It will allow only the string. We are making our object as a type safe. Okay, so that is the first advantage. Another advantage is the typecast is not required. There is no need to typecast the object. If you want to get the object, see, simply we are getting here. No, if I write here like that, so we no need to typecast it. If you are using the generics, no, that time we are no need to typecast it. We can store it directly. Okay, after that, another thing is that compile time checking, means it is checked at a compile time, so problem will not occur at the runtime. Okay, if we are getting the problem at the runtime, so it will not create at the uh, suppose if you are getting the error at the compile time, so you will not get any problem at the runtime, and it is good for the programmer. So better to handle the program at the compile time than the runtime. Okay, if you are getting the problem at the compile time than the runtime, it is good for the program only. Okay, these are the three advantages of our generics. Okay, so anyone have any doubt here that the generics are the set interface? Anyone have any doubt? Anyone have any doubt or understand? Can I explain it again? This thing, generics. Can I explain again? Huh? Tree set. Okay. Here. Okay. We will take the new reset. Okay. And this is called, this object is storing, means this is the generics. We can store in the objects here. Yes, dot add here. Okay. This time I'm adding the string value. Job. Yes, dot add. Can take here new integer value I'm taking this time. Yes, dot add. This time I'm taking another value. Okay, and simply will print that. Now it will print. It will print or not? We will try to run this one. It is giving the exception, that is the class cast exception it is giving, because string cannot be to class to the class, means it is saying that we cannot able to store string. Sorry, we will see. We try to remove the string. This is here also it is giving the error.
Generics.
It is not creating any problem. I think we can able to add only same type of value here. Integer cannot be cast to the class. Class context. I think it is following the sorting order, no? So we have to add only the same type of value here. We can add. We can add. We can try to add here. We can able to add this. Means we can, if you have, we want to add the values, we can add only same type of value. It is doing sorting, no? That's why I think. I will tell you this in second class. I will tell you this. What is the problem it is occurring, no? So I will tell you. Okay. So this is the thing. Another problem anyone have? Anyone have another problem? Understand, no, this one? Means preset, set, interface, and um, the generics. Anyone have any problem in that? Means any classes? Try to execute all the methods there, because we are going so faster. I know that. So you have to, means if you want to learn more, no. So we have a classes inside. In previous class, I have tell very well this thing. So you can go through that. Okay. We'll start. We have to start the servlet now, because servlet is very important. These things we can learn, but servlet is very important. That's why I'm taking this much. This is too faster. Okay. Okay. So that's it, guys. Try to execute this all the methods and all, and we will see the servlet in next class. Okay. Map we have pending. So map we will take at the last now.